Okay, good morning, students. The next topic which we have to study is about the galvanic cell. Up till now, we have studied about the electrolytic cells which convert electrical energy into chemical energy. Now, we have to study about electrochemical cells, which are those which convert chemical energy into electrical energy. A little bit of this part we have already studied in class 11th in the chapter redox reactions. We continue further only and we'll study again that part only which we had earlier studied. Now, if you take a zinc rod and you dip it into zinc sulfate solution, suppose I take a zinc rod and I dip it into a zinc sulfate solution, you know what happens? Zinc gets oxidized. Zinc loses its 2 electrons. You can see this diagram. Zinc loses its 2 electrons and comes into the solution as zinc ions, losing 2 electrons. Zinc gets oxidized. Similarly, if we have a copper rod dipped in copper sulfate solution separately, the copper ions which are present in the solution, because we are taking copper sulfate solution, they get reduced to reduce copper. Suppose we have taken a zinc rod which is dipped in copper sulfate solution. We've taken, हम क्या करें, हम take a zinc rod which is dipped in copper sulfate solution. What will happen? It will be a direct cell in which zinc will get oxidized and copper will get reduced. Now, as soon as I drop this zinc rod into zinc sulfate solution, we see that zinc gets oxidized. Now, since zinc gets oxidized, zinc comes into this solution as zinc ions, losing its electrons on this metal strip. All the electrons lost by zinc get collected on this metal strip, so that this metal strip gains a negative charge and the solution gains a positive charge. That means a potential difference is set up between the solution of its own, between the metal and the solution of its own ions, and since zinc is being oxidized, we will call it oxidation potential. If to this cell, in the bottom I have made, you can see I have made, similarly if you have a copper rod, so copper ions will get reduced, so again a potential difference will be set up between the metal and the solution of its own ions. Since it is reduction taking place, we will call it reduction potential. In the zinc rod dipped in zinc sulfate, oxidation is taking place, so the potential difference which is set up between the metal and the solution of its own ions here in this half cell will be called oxidation potential, and in this case it will be called reduction potential. And if we take a zinc rod and dip it into copper sulfate solution, that will simply set a redox reaction in which zinc will get oxidized and copper ions will get reduced simultaneously. Now if you take the zinc rod, this is at the bottom, you can see is a simple electrochemical cell. I have taken a zinc rod which is dipped in zinc sulfate solution. On the other end we have a copper rod which is dipped in copper sulfate solution. Now, as soon as zinc gets oxidized, मैंने अभी क्या बताया, the electrons get accumulated on this zinc strip. If we, through this external circuit, we connect a wire through a galvanometer and connect it to this half of the cell, that is copper rod dipped in copper sulfate, the electrons which were accumulated on the zinc strip will travel through the external circuit, through the galvanometer, and they will come into this solution. Now what will happen in these solutions? So here zinc gets oxidized, zinc loses electrons, these electrons get accumulated on the metal strip which move through the external circuit, through a galvanometer, and come into this half cell where there are a lot of copper ions. These electrons which are lost by zinc and which travel through the external circuit move towards this electrode, and here copper ions get reduced. So this half of the cell where oxidation takes place is called anode. This half of the cell where reduction takes place is called cathode. Here anode is negatively charged because electrons get accumulated on the zinc strip. Cathode here is positively charged. Now what will happen? The current will keep on flowing. After some time, when lot of zinc ions will get accumulated, negative electrons will get accumulated on the zinc strip, and zinc ions will get accumulated in this. These zinc ions will stop the external flow of electrons. In order to maintain the external flow of electrons, we introduce an inverted U-tube, which you already know is called salt bridge. It is a hollow bridge in which we take a mixture of potassium chloride or potassium nitrate with the colloidal solution of agar. A paste is prepared from these solutions and it is filled into this salt bridge. What is the function of the salt bridge? Number one, this salt bridge maintains a direct contact between the anodic half cell and the cathodic half cell. अगर हम salt bridge हटा दें तो there is no direct contact between the anodic half cell and the cathodic half cell. That is zinc rod dipped in zinc sulfate and copper rod dipped in copper sulfate. Number two, which is most important, is it helps us to maintain the electrical neutrality. How? When lot of zinc ions get accumulated in this, the negative ions, that is chloride ions or nitrate ions from this salt bridge, come into this anodic half where they get neutralized, because sulfate ions, zinc ions are positive and chloride ions are negatively charged. They get neutralized so that the current which had stopped due to excess of zinc ions accumulated in the anodic half cell again maintain their flow of current. So what is happening here? Salt bridge has got two important functions. Number one, it maintains a direct contact between the anodic half cell and the cathodic half cell. Number two, it helps us to maintain electrical neutrality. How? When excess of zinc ions get accumulated in the anodic half cell and they prevent the flow of electrons through the external circuit, chloride ions or nitrate ions which are present in the salt bridge, they come into this solution and they neutralize these positively charged zinc ions so that the flow of the current is maintained. So they maintain electrical neutrality. Now how do we represent a simple galvanic cell? Now actually what happened? What have we done? We have converted the chemical energy into electrical. Electrons are into electrical energy. Electrons are flowing from the anodic half cell to the cathodic half cell, but actually the current is flowing from the cathode towards the anode. That is from copper rod to the zinc rod. How do we represent a simple cell? If you see, it is metal. जो भी आपका metal है,